So after discussing about the meaning of the equivalent weight, let's talk about the methods to find out the equivalent weight. Now let's find out the equivalent weight in the case of acid, base, salt, and in the case of redox reactions. Now first is the case of acids. Now in the case of acids, the equivalent weight is equal to the molar mass divided by basicity. Now what basicity is actually? Basicity is the total number of H plus ions released by an acid. Let's take some examples which you generally see in your books and the question papers. The most common example is hydrochloric acid, that is HCl. Its basicity is equal to 1 and molar mass is equal to 36.5. And if we divide the 36.5 by 1, that is molar mass divided by basicity, we will get equivalent weight is equal to 36.5 divided by 1. In the case of H2SO4, the basicity is 2, molar mass is 98, therefore the equivalent weight will be equal to 98 by 2. In the case of phosphoric acid, the basicity is 3, its molar mass is 98, therefore the equivalent weight will be 98 by 3. In the case of phosphorus acid, the basicity is 2, its molar mass is 82, therefore its equivalent weight will be equal to 82 by 2. Now in the case of hypophosphorus acid, the basicity is equal to 1 and its molar mass is equal to 66, therefore its equivalent weight will be equal to 66 by 1. Now in the case of boric acid, the basicity is 1 and its molar mass is 62, therefore its equivalent weight is equal to 62 by 1. Now at the end, oxalic acid, the basicity is equal to 2, its molar mass is equal to 90, therefore its equivalent weight will be equal to 90 by 2. Now guys, these acids we generally see in the numericals present in our books and the question papers. Now, so at least these examples you should learn. He will expect you to know the basicities and the molar masses of these acids. Now let's discuss more about S3PO4, S3PO3, S3PO2 and S3PO3. You might be thinking that they all are having 3 hydrogen atoms but their basicities are different. Why is it so? Let's take the example of S3PO4. Now you can clearly see in S3PO4, phosphorus is attached to 3 OH groups. Oxygen is very electronegative and oxygen will pull the electron from hydrogen and hydrogen will replace as H plus ion. So in this case, the 3 H plus ions will release. In the case of phosphorus acid, you can see that 1 hydrogen is directly attached to the phosphorus. Phosphorus is not that much electronegative so that it can attract the electron from hydrogen. It can be released as H plus ion. There are 2 OH groups, therefore its basicity will be 2 as 2 H plus ions will be released in this case. In the case of hypophosphorus acid, we can see that there are 2 hydrogen atoms attached to the phosphorus and there is only 1 OH group. And if there is only 1 OH group, oxygen will attract electrons from hydrogen atom and H plus ion will release. And how many H plus ions will release? Only 1 H plus ion will release. Therefore, its basicity will be equal to 1. Now, boric acid. Now, in the case of boric acid, you can clearly see that boric acid does not give its own H plus ion. It accepts OH minus from water and gives 1 H plus ion. Therefore, it is monobasic. So, about more number of acids we will study in the chapter chemical bonding and molecular structure, P block and organic chemistry. Let's take the case of base. In the case of base, the equivalent weight will be equal to molar mass upon acidity. Now, what acidity is? Acidity is total number of OH minus ions released by a base. Let's take some common examples. The most common example is NaOH. NaOH, we have 1 OH minus ion it will release, therefore its acidity is equal to 1. Molar mass is equal to 40, and if we divide 40 by 1 we will get its equivalent weight, therefore the equivalent weight is equal to 40 by 1. The second example is calcium hydroxide. Its acidity is equal to 2, its molar mass is equal to 74, therefore its equivalent weight will be equal to 74 by 2. Now, very important case, that is ammonia. Now, ammonia does not have any OH minus ion, but it accepts one H plus ion to form ammonium ion. It means that it is monoacidic. Therefore, its acidity is equal to 1. Its molar mass is 17. Therefore, its equivalent weight will be equal to 17 by 1. Let's take the case of salts. Now, in the case of salt, the equivalent weight will be molar mass upon total cationic charge. Now, you can take total anionic charge also. Let's take some common examples. Now, NaCl is the most common example of salt. Its cationic charge is +1 because Na plus is there. Its molar mass is 58.5. Therefore, 58.5 divided by 1 will be its equivalent weight. The second example is magnesium chloride. Magnesium has 2 plus charge. Therefore, its cationic charge is equal to 2 and its molar mass is 95. Therefore, its equivalent weight will be equal to 95 by 2. The next example is AlCl3. AlCl3, aluminum is present. Therefore, the charge is +3. Its molar mass is equal to 133.3. Therefore, the equivalent weight will be equal to 133 divided by 3. In the next case, Na2CO3, there are 2 Na plus ions. Therefore, the total cationic charge will be equal to +2. Its molar mass is equal to 106. Its equivalent weight will be 106 divided by 2. In sodium phosphate, its total cationic charge will be equal to +3 and its molar mass is equal to 164. Therefore, its equivalent weight will be 164 divided by 3. Now, in the case of aluminum sulfate, that is Al2SO4 whole thrice, there are 2 aluminum atoms which will give 2 aluminum ions, that is twice of Al3 plus, that is total charge is +6, its molar mass is 342, therefore the equivalent weight will be equal to 342 divided by 6. Let's discuss about redox reactions. Now, in the case of redox reactions, the equivalent weight is equal to the molar mass divided by change in valency. That means we have to look at the change in valency. Now, there is a complete chapter, that is redox reaction, in the second book, but for now I am giving you a brief idea how to handle the redox reaction in this chapter. Let's take some examples. First is Fe is giving 2 electrons to form ferrous ions. It is the case of oxidation. So what is the change in the valency? Change in the valency is 2. Therefore, its equivalent weight will be equal to 56 by 2. Now, second case, Fe3 plus, that is ferric ion, it is accepting 1 electron, forming Fe2 plus. Therefore, the equivalent weight will be equal to 56 by 1. In third case, this is again oxidation and Fe is converted to Fe3 plus. The change in the valency is 3. Therefore, it is equal to 56 by 3. Now, this is a complete reaction, that is redox reaction, and we have to find out the equivalent weight. Now, there is Cu2 plus, it's converting to Cu. Don't look at the balancing because equivalent weight is always found for 1 mole. So Cu2 plus is converting to Cu, therefore its equivalent weight will be equal to 63.5 divided by 2. That is the equivalent weight of copper 2 plus cupric ion. Now aluminium. Aluminium is converting to aluminium 3 plus. The change in the valency is 3. Therefore, its equivalent weight will be equal to the molar mass 27 divided by 3. So the equivalent weight of copper is this, and the equivalent weight of aluminium is 27 by 3. Let's solve a question. Now in this question he is asking which of the following will be the equivalent weight of S3PO4. Now student think that S3PO4 is asked, therefore the equivalent weight should be m by 3. Don't do this mistake, right? Why? If S3PO4 is given, in this question NaOH is neutralizing S3PO4, but the number of moles of NaOH are not given. So what you have to do, you have to take all the cases in which NaOH neutralizes S3PO4. Let's take those cases. So the solution of this question will be now we have to find out the equivalent weight. Therefore, we have to take all the cases. The case number 1 is in this case 1 mole of NaOH is reacting with S3PO4. Now in this case you can clearly see that 1 H plus ion is neutralized. The second case, S3PO4 is reacting with 2 moles of NaOH. And 2 moles of water is formed. Now in the case number 3, now in the case number 1, 1 H plus ion is neutralized. Case number 2, 2 H plus ions are neutralized. Case number 3, 3 H plus ions are neutralized. Therefore, the equivalent weight of S3PO4 in the case number 1 will be equal to in the case number 2 it will be and in the case number 3 it will be. So all the answers are possible. Therefore, the fourth answer, any of these, is the correct answer. So the answer is answer number 4. Let's discuss some more questions.